Have you ever stared at a world map and just had a feeling that the full story isn't being told? That the familiar shapes of our continents are hiding a history so massive it would rewrite everything we think we know? Myths from every culture on Earth tell us about a time when giants walked the land, titans, Nephilim, beings of unbelievable size and power. We're taught that these are just stories, simple fairy tales. But what if they aren't? What if the proof of these giants isn't buried in some lost tomb, but has been hiding in plain sight this whole time? What if some of the world's most breathtaking natural wonders aren't natural at all? Think about coral reefs. We see them as glimmering, sprawling ecosystems, but what if they are actually the tombstones of a forgotten age? When you look closely, when you truly let your eyes wander over the patterns, the shapes, the impossible scale, a different story starts to take shape. A story written in stone, on a scale that beggars belief. We're about to explore the shocking idea that the world's coral reefs might just be the petrified remains of colossal ancient beings, a truth that could be hiding right under our noses. The story science gives us is a simple one. Tiny organisms called coral polyps secrete calcium carbonate over millions of years, slowly building these vast, intricate structures. It's a neat and tidy explanation. It paints a picture of a slow, patient, natural process. But another, more audacious theory suggests something else entirely. It asks us to imagine an ancient Earth inhabited by beings of a scale we can barely wrap our heads around. In this version of the past, a sudden global cataclysm ended their age in an instant, petrifying their colossal bodies where they fell. Their remains, this theory suggests, became the very foundations of what we now call coral reefs. It sounds like science fiction until you start looking at the exhibits people have put forward. And it only gets stranger. The clues, they say, are in the startling symmetry of these formations and the very layout of reef systems across the planet. Let's start with the big one, the Great Barrier Reef, the largest living structure on Earth. Look at it from space. Could it not, from a certain perspective, resemble a gargantuan spinal column stretching over 2,300 kilometers? Proponents of this idea ask us to see the individual atolls as massive, eroded vertebrae. They point to the deep channels and lagoons and ask if they could be remnants of a vast canal for a spinal cord. It's a shocking comparison, but one that's hard to unsee once it's pointed out. Of course, the scientific community calls this pareidolia, our brain's tendency to see familiar patterns in random shapes. The official story, first proposed by Charles Darwin back in 1842, is that reefs form around sinking volcanic islands. As the island sinks over geologic time, the coral grows upward, creating a barrier reef and eventually an atoll once the island is gone. Modern science has built on this, showing how fluctuating sea levels during ice ages also helped shape the reefs we see today. But does that explanation truly account for the startlingly biological shapes we see? Or could it be a convenient narrative that steers us away from a much stranger possibility? Now let's zoom in from the massive to the microscopic. Take a look at the very substance of a coral skeleton. It has a porous, lattice-like structure that is unnervingly similar to a type of bone in our own bodies. Cancellous bone, the spongy tissue you find at the ends of long bones. Both are lightweight, yet incredibly strong. This resemblance is so striking that modern medicine actually uses coral in bone graft procedures. A piece of coral can be implanted into human bone, and over time, the body's own cells grow into it, replacing the coral with new, living tissue. The question is, why does this work so well? The official explanation is that it's a happy coincidence of natural engineering. Scientists point out that coral is made of aragonite, a form of calcium carbonate, while bone is a mix of collagen and hydroxyapatite. For the medical procedure to work, the coral has to be hydrothermally converted in a lab to change its chemical structure into hydroxyapatite, essentially tricking the body. But what if it's not a trick? What if the reason coral can be so easily transformed into a material our body accepts is because it was once bone to begin with. Perhaps the aragonite is just the result of a petrification process, a chemical echo of a biology that time forgot. If we were really looking at the remains of petrified giants, you wouldn't expect to find just one. You'd expect to see them all over the world. And when you look at a map of major coral reef systems, that's exactly what you see. They are heavily concentrated in a band around the tropics. The mainstream explanation for this is that reef-building corals have very specific needs to survive: warm, shallow, clear, and sunlit water. This, science tells us, explains their distribution. But what if we look at it through a different lens? What if this distribution isn't about where corals can grow, but about where colossal beings fell? The theory of plate tectonics tells us that our continents are constantly, slowly moving. Imagine if these giant remains were dragged and scattered across the globe, along with these shifting tectonic plates over millions of years. Could the ideal conditions for coral growth just be the places where this ancient, petrified bone material is most exposed, allowing today's tiny polyps to move in and build their colonies on the surface? In this view, the living reef isn't the structure itself, it's just the moss growing on ancient gravestones. The entire scientific model for how coral reefs form rests on the idea of gradualism, slow, steady growth over millions of years. Scientists tell us that massive corals might only grow a centimeter or two a year, and that core samples show layered growth bands, like tree rings, proving this slow accumulation. This idea is a direct contradiction to the theory of a sudden petrification event. But even outside of this specific theory, some have questioned the gradual model. Proponents of flood geology, for example, argue that many fossil reefs found in rock strata aren't intact structures, but are jumbled messes of fragments, suggesting they were torn apart and deposited quickly in a catastrophe. What if a global event, a massive flood, a chemical deluge, is exactly what happened? A sudden catastrophe could explain why these massive forms were preserved in place rather than decaying naturally over time. The slow growth model requires these structures to maintain their biological shapes through millions of years of change, whereas a sudden event could explain their existence as perfectly preserved specimens. This leads to the biggest question of all. If this idea is so compelling, why is it dismissed as pseudoscience? Why isn't it being seriously discussed? Those who support this theory argue that the answer is control. Our current historical narrative is one of slow, linear progress from primordial soup to us. The discovery of a previous age of giants would shatter that timeline. It would force us to ask what they were, where they came from, and what happened to them. Proponents claim that powerful institutions have a vested interest in maintaining the current story. Darwin's theory of reef formation isn't just science, it's a pillar of a modern worldview. To question it would be to open a Pandora's box. Admitting that history might be a lie, they say, is a truth too dangerous for us to know. We've looked at the anatomical anomalies, the cellular connection between coral and bone, the global distribution of reefs, and the questions surrounding the timeline of their creation. Taken one by one, each point can be explained away by mainstream science as coincidence or misinterpretation. But when you put them all together, a curious pattern emerges. We're not here to tell you what to believe. We're just asking you to look at the world with fresh eyes. Is it really more of a stretch to believe in ancient giants, a concept found in myths all over the world, than to believe that trillions of tiny polyps just happened to build a perfect 1,000-kilometer replica of a spinal column by chance? We've been taught to see our world as a product of random processes, but everywhere we look, we see patterns. Why should the largest biological structures on Earth be any different? The next time you see a coral reef, will you see a collection of tiny animals, or will you see the silent ghost of a giant? The choice is yours. Don't just take our word for it. Do your own research. Look at the satellite images, the science, and the ancient myths, and decide for yourself. Share this to help awaken others to the questions. What do you think? Have you seen other formations that defy the simple explanation? Let's connect the dots together in the comments. The journey to uncover our lost history has only just begun.